Hi friends, and welcome again. And this is continuation of video number 3 or lecture number 3, you can say. Okay. And as you know, a series of lectures I'm preparing for this 7th grade science students. And the chapter chosen right now is chapter number 8. And the name of the chapter is chemical reactions. Already in my 2 previous videos, I have started with the lecture, and this is my 3rd video in continuation. So, according to if you go by this chapter, this is the thing that we have to start with. That is metal reacting with dilute acids. Okay. So let us get started. So let us take an example. Now, initially, let me tell you, in general, any metal, so let me write that for you. In general, if you take any metal, say M for metal, right? Any metal, when it is reacted with any dilute acid, okay? Once again. Mhm. Okay. So, in general, if you take any metal and if you react with any dilute acid, okay, the product form will be a salt and hydrogen gas. Okay, these are the product of this reaction. Okay, hydrogen gas, and these reactions are all exothermic reaction plus delta H. That is, heat is given out. Now this is very general reaction. Okay, any metal reacting with hydrochloric acid will give you a salt and hydrogen gas. Okay, now if you take in particular magnesium as a metal, and if you take in particular hydrochloric acid, okay, dilute hydrochloric acid, then the salt form will be magnesium chloride. So this magnesium chloride is a salt which will be formed. Salt is a general name. Magnesium chloride is a salt formed when magnesium reacts with hydrochloric acid. Okay, and of course the hydrogen gas is also formed. Okay, so this is a chemical reaction in which you will find that heat is evolved or given out. So I'll write plus delta H also at the end. Okay. Now if I want to indicate or if I want to show this particular chemical reaction in word form, okay. So this is that word form chemical equation. Magnesium, you have to write in word magnesium plus dilute hydrochloric acid giving you magnesium chloride and hydrogen plus delta H. Now, if you want to show symbolically, okay, you can show one atom of magnesium by this red circle and this two green circles, they are showing you hydrogen atoms, and these two black circles are showing chlorine atoms. Okay, so this is hydrogen chloride or hydrochloric acid, okay, which can be shown by two green circles and two black circles attached together, right? And then magnesium chloride consists of one magnesium atom and two chlorine atoms. So in the center you can see red circle indicating one magnesium atom, and these two black circles are indicating two chlorine atoms, right? And you can see these two hydrogen atoms, green color circles, are also shown over here. So this is a complete balanced chemical equation. What I mean by balanced chemical equation, the number of atoms of a particular type will be same on both the sides of the chemical reaction, on the left as well as on the right. So if you see this magnesium atom, okay, shown by red circle, there's only one on this left hand side, and on the right hand side also you'll see only one. This hydrogen atoms, you can see two green circles on the left hand side. On the right hand side also you will be able to see two green circles. Okay, and the two black circles on the right and left hand side are indicating chlorine atoms, two chlorine atoms. So on the right hand side also you will see two black circles. Okay, so you will see that all the elements, okay, magnesium, chlorine, and hydrogen are same amount atom wise on both the cells. This is known as a balanced chemical reaction. Now, just for sake, if some students, are interested, when they go to the next grade, in the 8th grade, you will start writing in the form of symbols. Okay, so for magnesium, the symbol is Mg, capital M followed by small g, plus hydrochloric acid is HCl, and there's a 2 placed in front of that HCl. HCl is the formula for hydrochloric acid, but this 2 placed in front of that HCl indicates that there are 2 molecules of hydrochloric acid. Okay, then magnesium chloride, the formula is MgCl2. Okay, and hydrogen gas, the formula is S2. Okay, and you can see plus delta H I'm writing for indicating that it is a exothermic reaction in which heat is evolved, right? Now, in all exothermic reactions, now this is an exothermic reaction we have seen in the previous lecture number 2 also. You must have seen I have talked about potassium reacting with water. That was also an exothermic reaction. I talked about hydrogen and oxygen combining together to form water. That was also an exothermic reaction. So there are so many exothermic reactions. Okay, and 3,4 we have already discussed. So in all these exothermic reactions, these are the 3 features that you will find. Number 1, heat is given out. So in all exothermic reactions, invariably heat is given out. Second, temperature of the surrounding increases. Obviously, when the heat is given out, it will be going into the surrounding, and when the surrounding is getting heated, okay, because of the heat energy, the temperature of the surrounding is going to increase. So obviously the temperature of the surrounding increases. Okay, and the third thing that you will see in exothermic reactions is, in some cases, along with heat, light and sound energy is also given out. Now this is nothing but heat energy can be also seen in the form of light or sound energy. So it's always possible that along with heat energy you will be able to see light energy also, and the sound energy also coming out. Okay, so these are the 3 characteristics, or you can say the 3 main features of the exothermic reaction. Rise in temperature for a particular exothermic reaction is the same. Now this is very important statement. Okay, for a particular exothermic reaction, for example, if you take this particular reaction only, magnesium reacting with hydrochloric acid giving you magnesium chloride and hydrogen, this is a exothermic reaction. Now in this particular exothermic reaction, okay, irrespective of the initial temperature and the final temperature, okay, the rise in temperature will always be same. Okay, so suppose in one case the initial temperature was 18 and the final temperature was 42, then the rise in temperature will be 24 degrees centigrade. In other case, suppose the initial temperature was, instead of 18 it was 21, then automatically you will find that the final temperature, that is on the completion of the reaction, the final temperature will come to 45 degrees centigrade. You will see that. Okay, so 45 minus 21, again 24 degrees centigrade. So what is indicated here is that the rise in temperature will always remain same, okay, for a particular reaction. In this case, this is that reaction. Okay, what I want to add here is, suppose you take more quantity of magnesium, okay, then it is possible that this rise in temperature may be more. Suppose you take some different type of a metal, not magnesium, but more reactive metal, more reactive than magnesium. Okay, then also you may get a higher rise in temperature. Not, it will not be 424, it will be more. Okay, so depending upon the quantity of the metal or the acid you are taking, depending upon which metal or which acid you are taking, okay, the rise in temperature may be different. But for one particular fixed amount of magnesium and hydrochloric acid, you will get the rise in temperature as same. Okay, fine. Okay, now let us go for some question and answer session. Okay, and whatever we have discussed so far in these two past lectures, two past videos, and this third video that I started right now. Okay, let us try to see whether we can answer these questions. And these are some 8 questions, right? Okay, so let us start answering these 8 questions one by one. Question number 1. Now, all these questions are from your textbook, right? So, question number 1. What is needed for combustion to take place? Okay, so answer should be, now everybody knows by now that oxygen is needed for combustion to take place. Okay, this is already discussed in my lecture number 2. Okay, question number 2. What is an exothermic reaction? Okay, so answer should be what? The definition of exothermic reaction that I have discussed in my lecture number 2. So answer should be any chemical reaction that evolves heat or thermal energy along, one second. Yeah. So any chemical reaction that evolves heat or thermal energy along with light and sound energy and increases the temperature of the surrounding is called as exothermic reaction. So I have just written the definition of the exothermic reaction. Okay, so that was answer to question number 2. Question number 3. How can you tell that burning is an exothermic reaction? Okay, so let us answer this question. So burning is a process where burning is a process which results in the evolution of heat or thermal energy. Now, all burning process, you know, it results in the evolution of heat. So heat energy or thermal energy is evolved, and during which light energy is also given out, okay, along with light energy. Also, it increases the temperature of the surrounding, and in all burning processes, we see that the surrounding temperature always increases, okay. And these are nothing but the features of exothermic reaction. So it has to be an exothermic reaction. And that is why burning process is an exothermic reaction. That understood? Let us go to the next question, question number 4. It says, what are the products when magnesium and hydrochloric acid react? Okay, now this I started in today's lecture only. And the answer will be magnesium chloride. I told you about the salt and hydrogen being formed when a metal and an acid reacts. Okay, so in this case it is magnesium, which is the metal, and hydrochloric acid, which is the acid that they have taken. So the product will be magnesium chloride and hydrogen gas. These are the product of this particular reaction. Okay, so that was answer to question number 4. What is question number 5 saying? How did Sophia and Marcus know when the reaction had finished? Now here I would like to pay attention on this particular arrangement or this particular scenario where there are 2 students. She is Sophia, he is Marcus. They both are performing some experiment or they are investigating something, and what they are investigating is written over here. Okay, and I'll just tell you what they are doing. They both, they both took some 10 centimeter cube of dilute hydrochloric acid in test tube. Okay, so both the students, what they did, they took 10 centimeter cube of dilute hydrochloric acid in the test tube. Okay, each of them. And then what they did, they added same amount, how much is not mentioned, but same amount. Okay, same amount of magnesium metal was added by both of them to this hydrochloric acid in the test tube. Okay, so the amount of magnesium is also same, and the quantity of dilute hydrochloric acid taken by both is also same. Okay, then the reaction took place, okay, in the test tube in both the cases, and after the reaction they measured what was the temperature, and before reaction also they measured what was the temperature. So initial and final temperature was also measured by both of them, and in the table it is shown here. In the case of Sophia, the initial temperature was 18 degrees centigrade and the final temperature means when the experiment or the chemical reaction in the case of Sophia got over. Okay, that time what was the temperature? It was 42 degrees centigrade. In the case of Marcus, initial temperature was 21 and the final temperature was 45 degrees centigrade, right? Okay, so this is what the investigation tells you that was performed by Marcus and Sophia. With respect to this particular investigation, you have to answer this question number 5, 6, 7, and 8. Okay. So question number 5 is, how did Sophia and Marcus know when the reaction has finished? Okay. So very good question. How these two students will come to know that the reaction that they have started, reaction between magnesium and dilute hydrochloric acid, has uh, finished or it is complete. Okay. So answer is, let us see what is the answer. The answer to question number 5 is, and I've just written the answer, when the fizzing or the effervescence stops. Now what happens whenever dilute hydrochloric acid and magnesium reacts? Okay, when you add the two things, okay, immediately a fizzing sound comes and effervescence is seen. In this chemical reaction, effervescence is seen. And this effervescence will go on for some time, and then afterwards it will stop, and the fizzing sound will also stop. So when this effervescence or the fizzing sound both stops, okay, we can conclude that the experiment is, that the chemical reaction is over, is complete. Okay. So the answer to that question number 5 should be this: when the fizzing or the effervescence stops, then the chemical reaction is finished or over. Okay. So in both the cases, the answer will be same. Okay. In the case of Sophia and Marcus, when the fizzing sound stops or when the effervescence stops, that means the chemical reaction is over. Question number 6 is, Marcus thought that more chemical energy has been changed to thermal energy by his reaction because in his experiment the end temperature was higher. Okay. Now according to this question, the question, try to understand the question. Marcus, when he performed his experiment, the final temperature was 45 degrees centigrade. In the case of Sophia, when she performed the experiment, her final temperature was 42 degrees centigrade. So on the basis of this, what Marcus was thinking is, because in his case the final temperature is 45 degrees centigrade, and in Sophia's case the final temperature is 42 degrees centigrade, which is slightly less. So Marcus thinks that in his case the chemical energy converted to thermal energy is more. Okay, that is what Marcus wants to conclude. But Sophia thinks other way. Sophia thought that both the reactions, both means in her case as well as in Marcus' case, in both the cases, the reaction changed the same quantity of chemical energy into thermal energy. So according to Sophia, she thinks that in both the cases, the same amount of chemical energy is converted into thermal energy. Now, what do you think whose statement is correct? And you have to explain why. That is the question. So let us check the answer. So the answer says that, answer number 6. Sophia is correct because the increase in temperature is the same. Now, according to Sophia, in both the cases, the change in temperature, the rise in temperature was same, isn't it? See, you must have seen in the case of Sophia, the rise in temperature was from 18 to 42. Okay, 18 to 42, that is 24 degrees centigrade. And in case of Marcus also, the rise in temperature was from 21 to 45. So increase in temperature is again 24 degrees centigrade. So in both the cases, the rise in temperature is same. So the rise in temperature being same, Sophia's statement is correct because Sophia's statement is that in both the cases, the rise in temperature is same, 24 degrees centigrade. The same amount of chemical energy is converted into thermal energy. Okay. So the right answer is Sophia's statement was correct, not Marcus' statement. Now let us go to question number 7. Question number 7 says that explain why it is good idea to wear safety glasses while carrying out this investigation. Okay, now this is very simple. Now safety glasses you should wear because safety glasses should be used to protect eyes from the spilled acid. So it is possible that you are handling acid you are adding magnesium to it, the reaction is vigorous, effervescence is taking place. So there's all possibility that if the effervescence is uncontrolled, some acid may spill out of the test tube and it may enter your eyes. So it is a good idea to wear safety glasses, right? So that was answer to question number 7. Now question number 8. Let us see what the question says. Okay, Sophia and Marcus both wondered how they could produce a higher uh, temperature change. Okay, so both were wondering what can be done so that our rise in temperature will be higher. Now in both the cases, now we can see that the rise in temperature is 24 degrees centigrade. Okay, but suppose if they want the rise in temperature to be more than 24, what should be done? So Sophia and Marcus, they were wondering about what can be done so that the rise in temperature is more. Their idea included, so they thought of 3 things. Okay, adding more magnesium in this reaction. Second, using a different metal other than magnesium. Third, using a different acid. Okay, so all 3 thoughts came to their mind. Okay, now you have to answer to this question. We write each of these 3 ideas as a scientific question to be investigated. Okay, so write each of these 3 ideas as a scientific question to be investigated. Okay, so basically the question asked is uh, what these people are thinking. One is thinking that maybe increasing the magnesium or taking a different metal. So which one will be a good idea? Okay, so the answer to this question is, this is a very subjective question, so answer will also be very subjective. It will depend. So you'll have to carry on an investigation and see. So suppose you take some other metal which is maybe more reactive than magnesium. Okay, then it may happen that the rise in temperature will be more. But if you take a metal which is less reactive than magnesium, then the rise in temperature will not be more. On the contrary, it will be less. Okay, so the answers are very, very subjective. Okay, so all depends. So the answer to this is, it is subjective based on the result obtained. Okay, so what will be the result? What metal you are taking and what acid you are taking and how you are combining them. The result will depend upon the investigation. So answer will be very, very subjective. Okay, I hope you understand those 8 questions, how to answer them. And that's all for today's lecture. Okay, and these 8 questions I have explained you very nicely. These were all from your textbook. In the lecture number 4, or part 4 of this series, I may start with this endothermic reaction. Okay, so till then, goodbye. Take care, all of you. See you.